The jerk in that car is just too much. Jerk. 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 So when an engineer is talking about the jerk in that car, they may not be talking about that a-hole over there in the car driving who cut you off, because they actually could be talking about the third derivative of position. Maybe. It would also be the second derivative of velocity or the first derivative of acceleration. Now, everything that I just said might have been more jargon upon jargon if you're not an engineer. Well, let's break that down. First of all, when I said derivative, that's a calculus or math term. We're basically saying the change in something. So when I talk about jerk being the first derivative of acceleration, I mean that jerk is the change in acceleration. And I want you to have a physical, intuitive sense of what that means. Let's say you're cruising along in your car, and if you were going at a nice, even 30 miles per hour, totally unchanging down the road, there is no acceleration, all right? Acceleration is zero because you're not changing your velocity. You aren't going to feel any forces on you. We might recall that force equals mass times acceleration, F equals ma. And that means when acceleration is zero, the force is zero, and you aren't going to feel anything. Now, imagine you start pressing on that gas pedal. You press the accelerator. The hint is it's called an accelerator. And so you accelerate. It means you have a change in your velocity. It goes from 30 miles per hour to, 40, 50. You're just increasing your velocity steadily. Imagine there are no cops around. You can just do that. And you now feel a force. You know how when you start accelerating, you get pushed back kind of because you're feeling that force. And let's say you're a really gentle driver and you're doing this nice, even acceleration. Your acceleration is there now, but because it's a constant acceleration, the force that you feel is also constant. It would be like I was pushing on your shoulders gently with the same force the whole time you were driving. Can you imagine that? Like you're being pushed back, but it's the same force that you feel on your body the whole time as you accelerate. That is acceleration that is constant, and your jerk is still zero. The jerk is still zero. Okay, now imagine that your crazy friend is driving, and this person likes to accelerate really irregularly and pressing on the gas pedal here and there and braking and whatever. Your acceleration is no longer smooth, is it? No. If someone were holding your shoulders while you were driving to simulate the forces that you feel now, it's not a constant force pushing you back. No, it's like shoving you back and then bringing you forward and shoving you again as if they were like trying to perform CPR on you, pushing and then back and pushing back and pushing back. That acceleration is no longer constant, and you can tell because the force on your body is not constant. F equals ma. If your force is not constant, your acceleration is not constant. And I say that making the assumption that your mass is not changing. I'm assuming you're not losing any body parts. The driving isn't that bad yet. So yeah, if your mass is the same and your forces are drastically changing all over the place, then your acceleration is changing. And now that you are experiencing a change in those forces or a change in the acceleration that you feel, you know that you are now experiencing jerk. That is jerk. And if you got a lot of jerk in your car, nobody really likes that. Who likes jerks in their car? Whether it's that like person who makes you mad or that irregular acceleration and forces that you feel. Nobody, usually, unless you're on some kind of ride or whatever. Engineers who deal with the design or analysis of moving things have to think about jerk. If they deal with kinematics and mechanics, they gotta probably control that jerk. For example, when I used to work on robots, we wanted to have a less jerky robot, which again, sounds like I'm making a really nice robot or someone who's at least not passive aggressive. But no, I mean a robot that is more smooth in their motion, one that doesn't rapidly change acceleration all the time. Because if it does, you're going to have really irregular motion that freaks people out, like that little girl in the horror movie that comes up from the well, jerky joints and whatnot. Or you're going to literally hit somebody and talk about irregular forces that bodies will feel, well, yeah, that robot is not going to be exactly welcome in your home. And then cars, of course, any jet or train or spaceship or whatever, you all got to think about jerk. Jerk is such an interesting word. It's also related to velocity and position and acceleration and snap. It is my engineering word of the day. Hi, this is your host, Pius. Thanks for listening to the Engineering Word of the Day podcast. You can follow all the projects of Pios Labs on Instagram. If you go to Pios Labs, P-I-O-S-L-A-B-S, you can follow Pios Labs on Twitter, Facebook, all those places, and find out more about not just this podcast, but all the other engineering education projects that I do. Thanks.